Hello, my name is Christian Williams. This is my Circ09 A attempt. The date is November 19th of 2021. I wanted to start very briefly by saying that I am taking a risk with this assignment, um, just for my own sort of sanity, basically. So the way that our Circ9 A attempt was worded, we are working with making it better and using the full range of our servo. We will be using an additional component, one or two of your choice, that makes something unique, and modify the programming C language to make something meaningful happen. I have worked with the servo before in my Circ A attempt and in my Circ 4B attempt, and I have mapped a servo to a potentiometer and a potentiometer to a servo, and pretty much every other sort of combination before, and I am quite frankly tired of using that component. So I am taking great liberty in using additional components, one or two your choice, that make something unique, and I am relying on that heavily. The reason why I feel like I can do that, under light controlled servo and using the full range of your servo, we have been encouraged to use a map function. I will also be using a constrain function, and I will also be wiring up a component to our pin 9 and so on. I will just not be using the servo component specifically. I will be including a library. I will be using this map function. I will be using the constrain function. It will just not be with the servo. That is the risk I am taking with this assignment, but I wanted to kind of try something a little different than what I felt every other student was kind of doing, just to, do something interesting. So let me know what you think with this. So, for my Circ9A attempt, a little bit of real world history here. I've been recently looking into synesthesia, which is an interesting condition or range of conditions. And I also have my favorite author named Brandon Sanderson. He wrote a book called Warbreaker that included a hard magic system that could grant someone perfect pitch but towards colors. So perfect pitch, you could kind of tell if something is a perfect fifth from one another, or perfectly replicate a specific note and know if something is out of tune or not. Those same kind of sensations and abilities in this magic system would apply to colors. So you could, in theory, have a perfect fifth of reds. That may sound a little weird in practice, but it was explored to fantastic extent in Brandon Sanderson's work. So this project kind of was definitely inspired by that. Now, I don't necessarily have a color sensor yet. I didn't try to explore that necessarily, but I do have a light sensor. So I'm going to create a monochromatic version of chromesthesia using my Arduino. And I will be doing that using the photoresistor, a piezo buzzer, and a few other bits. Chromesthesia is a phenomenon where hearing a certain sound creates the sensation, hallucinatory or not, of a certain unique color. For example, there is a composer who, as I understand, whenever he heard a trumpet, saw or had the sensation of the color red. So trumpet equaled red in his brain. And there is other individuals, like there was a colorblind person who could still see colors when he read certain words. These words became kind of fixed to certain colors, but because he didn't necessarily have the concept of colors, he called them Martian colors, which I thought was kind of funny. All right, now to the actual programming itself. First off, I am including a library. Similar to how you would do it with a servo, but because I'm using a piezo device, I am including a pitches library into my program here. This pitches library, I explained in a previous A attempt, assigns a variable to each specific value. These values correspond to hertz or other electrical signal impulses that will be pushed through a piezo and will replicate that note. So these notes, for example, C3 refers to a specific spot on the register, and so on. So I could interpret music saying, oh, this is a C4 followed by a D4 for 2 beats, followed by a rest, and then followed by an E4. That way, I don't have to memorize all of these numbers for hertz. I just have to know the notes. It's a very useful library when you are working with a piezo device. So I have included it here because chromesthesia, we have to be able to hear a sound. I have also created a variable to hold a sensor value. The sensor in question is our photoresistor, and we have a low value and a high value. We also have an LED pin plugged into 9. This will only be used when we calibrate. How we calibrate is by using void setup, because void setup only run once in the program when you first turn it on. So when it first turns on, it's going to calibrate. The first thing it's going to do, it's going to identify the LED pin and switch it to output, and then immediately turn that LED on. That indicates to us that the Arduino is currently calibrating the photoresistor. Calibrating, we're just waving our hand or turning on a light or something near the photoresistor. While we're doing those actions, the highest value, while we're doing those actions for the first 5 seconds, I should mention, the highest value it records, it will set to sensor high. And the lowest value it records will be set to sensor low. This gives us a usable range. Of light that's relative to our room. So we could, this is basically how we could detect like the ambient light in the room and then what a shadow or what a light is like. So you could take this outside, for example, shine a flashlight on it, and it would know what it would know what the difference is. After those 5 seconds, it will turn our LED off using this digital write function, and then we will go to our void loop. And this is something that it will continue to do after the calibration phase. During that loop, we have our sensor values still set to our photoresistor, and we are mapping, there's that map function, mapping that sensor value so that sensor low and sensor high become 0 and 1023. This will help with our system here because of our photoresistor. This now becomes the new range. This constrain function just kind of helps us clean up a little bit of any garbage data coming in, because if for some reason our photoresistor or a signal gets in that's greater than 1023, our system's going to ignore it. It basically, sensor value only recognizes values from 0 to 1023. And then we get into if and else if statements. We've covered decision statements, so I won't go into there. We are using a logic statement here, along with a relation operators here, to determine what note it should play dependent on the level of light in the room. In this case, our piezo is plugged into pin 8, or, well, we'll get to the wiring in a second, but our piezo is ultimately receiving signal from pin 8. It will play this note for 40 milliseconds, and it'll continue going down the line here. As you can see, there are a lot of notes, so we have quite a range. The delay is set to the delay is set to 80 milliseconds. The note only plays for 40 milliseconds, and the reason why I did that is so we have a dut 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 kind of note as opposed to just a blaring noise. Now on to the wiring. Fun fact, the program has been playing in the entire background, but as you can see in my wiring here, I have a potentiometer that was not addressed in the programming. What that potentiometer is doing is controlling the current sent from the Arduino to the piezo. Currently, it is turned all the way off. This is basically just a volume button. So the Arduino is sending all these signals through that red wire into the potentiometer. That potentiometer is controlling the current into the piezo here, which is to ground, using this little sensor pin on this side of the piezo. You can see I'm bridging the gap to get a use of this. There's our LED calibration light, and that up there is our photoresistor. So I am going to turn this knob, and you will hear this piezo suddenly start making noise. Okay, so those noises you hear are the notes that I've assigned to this range, and that is an audio interpretation of all the sensory information that photoresistor is playing. So you probably saw it, but if I wave my hand, you can see the shadow here. You can see exactly what we're doing. It is detecting the light in the room and sending out a sound. It is essentially monochromatic synesthesia, or chromesthesia. So, and we're just going to turn that off by twisting the potentiometer. So there we go. I have included some interesting components into this, using the potentiometer to control the volume of the piezo, and in addition to the photoresistor and the LED. And I have created something that I believe is fairly unique. I had a lot of fun with this, as you might imagine. And I think I had more fun doing this than if I had just plugged in a sensor or just plugged in a servo. So I enjoy this project. Thank you for watching. And go look up synesthesia. It's very, very fascinating.